All right, so I'm going to be going over homework packet 5.4. Just remember that it does say you can skip 5.12. I am going to go over 5.12 anyways, just so you guys can kind of learn it, but you do not have to do that one. Okay? All right, so here's the first page that I was talking about. Let me move my head down here a little bit out of the way. Okay, so it starts off with saying Tasha has only, I'm going to say $5, but has a goal of doubling, but I'm going to say tripling for my example. Doubling just means you're multiplying times 2, whereas so I'll say times 2, whereas tripling is like times 3. The total amount of money she has saved every month. So she's basically going to start off with $5 or start with 3, and then she's going to triple that money every single month. Okay, so let's kind of write out what that actually would mean. So if she started at month 0, which would be $3 or $5, every month she's going to try to double that, triple that. Okay, so in other words, the next month, after 1 month, she's going to triple what she started with. In other words, multiplying times 3, and then she would keep doing that every month. The next month she would triple that, so then it'd be 45. Triple that again, multiply 5, and then you get 135, and then it just keeps going, right? So it's like this huge increase every month. It's not just like a small +5, +5, +5. It's actually multiplying. So it's a little different in this case. So it's not a y equals mx plus b equation. This is a different kind of equation for things that grow by multiplying or by decrease by dividing. It's called growth and decay. And that equation is y equals a times b to the x. Now, the a in this case is your starting value. That's where we're starting, okay? And then your b, or actually it's also like the y-intercept, I should say. So b is not the y-intercept. So I know that would be confusing to some of you guys because usually b in your mind is like y-intercept on y equals mx plus b. But in this case, b is your rate, almost like kind of like your slope. It's your rate of growth. Okay. Now remember, you're multiplying something, not adding and subtracting it. You're multiplying something here. So the rate of growth is a little bit different than just slope on a flat line. Okay, so in this case, with Tasha, she is starting with $5. So we're starting at 5. That's our A value. And then she is tripling every month. So then our B value would be 3. And then we raise that to the power of X. So our input for every month we plug in there and say, if I said, how much money will she have after 20 months? You would plug it in there. And 3 to the 20, if you think about that, that's a huge number. So after 20 months, when you're exponentially growing, that's huge. And sometimes that's how the stock market works a little bit, except the growth values aren't as big. Okay, so now Tasha's brother, Clifton, is going to copy Tasha's savings plan exactly. Okay, so what that means is that he's also going to start with $5 and then triple every month. So let's actually write that down, because basically it's going to say, write an equation for this, right? So let's just copy that down. Okay, but because he's brother and he wants to annoy her, he always wants to have more than her, and it's like competition, right? He has $8. You have 10. He has $8 saved and hiding in the dresser. So we're not including that in tripling, right? We're not starting with it. He's still going to start with $5, but on the side, like somewhere else, he's going to say, I got $8 over here in the drawer. Okay. So what that means then is that we're going to add 8 to the function. Okay. So that's the only difference there, is that value there. We're going to add 8 to it. Okay. So now let's graph each of these functions. Okay. So now here, I've already got some values written out here. Okay. And then here, let's see what that would look like. Okay, so I'm still going to start with 0, 1, 2, 3, right? And if I plug in 0 here, what would I get? Well, I would get the same thing. If I plugged in 0 here, I would get the same thing I get over here, 5. The only difference is now I'm going to add 8. So basically, I take this number and add 8 to it. So 5 plus 8, 13. What did I get for 1 here? 15. So add 8, I get 23. Here I got 45. If I add 8, I get 53. And here I would get a whole lot more. Okay, so that would be 143, right? All right. So here's the deal, and probably why we told you to skip this one is because the graph that we gave you, it sucks. And then it's kind of hard to graph this function, the one you would have to make on this graph. All right, so what I'm going to do to help us out, though, is since I got numbers going all the way up to like 45, let's make this go by tens. So that we'll say this is 10, 20, 30, 40, 50, 60, 70. Okay, so that'll help us out with the scale. So that means this is negative 10, negative 20, blah, blah, blah. But we're not graphing down there because nothing's negative anyways. Okay, so for the first one, it'd be 0, 5. Okay, so it'd be right here. Now, here's the issue with this one, is that when you create these graphs, you actually need some negative x values. Okay, so what I'm going to actually do is add a -1 and -2 to both of these. Now, the only issue with that is that means I would have to plug in a -1 into the x value, which means this is now a negative exponent. And I start plugging those in, it becomes a little difficult to figure that out. So I'm going to use Desmos to help me out with that. So what I'm going to do is I'm create a table, and I'm going to basically type the same function. So 5 times 3 raised to the x power. So that means I have to click on the keyboard down here and click on that b. Oops, sorry, I meant to be over here. Click on this b value to get an exponent, and I'm going to put x. Now, to complete a table, this x value and this x value need to match. Okay, so now once you get that, you know you're good. And I'm going to type in some of those x values. So these x values that I have here, I'm going to start with the -2 and -1. So -2, -1. You could see those would be hard to calculate, right? I mean, you could calculate them. They're fractions. It's doable, but I'm just showing you an easier way to get them. And I'm going to type in those other values that we found too. So 0, 1, 2, and 3. Okay, so now we already found those values, but I needed these ones. So it's like about like 0.56, and this is about 1.67. Okay, so right here, this is 0.56, and this is 1.67. Okay, let me just verify that. Yeah, so the -1 was 1.67, and then the -2 was 0.56. Okay, so let's also include those in our graph. So I'm actually going to start with the -2. -2.56, that's like right on the line. Then I go to -1, it was 1.67. So maybe I'll just make it slightly higher, like barely higher, because I mean, the scale is by 10, so can't make it too much higher. Okay, so now at 1, we've got 15. So that'd be 1 and 15 there. At 2, we're starting to climb here. We're going from 2 all the way to 45. And then when we get to 3, now we're just off the charts. We can't do any more. Now, what you'll notice is you start to kind of create this curve pattern. Okay, and actually, if you guys go over to Desmos and you click on this gear right here, and you click on now the color button there, you can click on lines, and it'll actually connect all those dots for you together. And just because we are just going by kind of like ones, I'm going to do a dash line. Doesn't matter, but you can just see that there's like this curve pattern going on, and it comes down, gets really close to like the x-axis here, or where y equals 0, and then it just shoots up. So that's the kind of pattern we want to copy. So I'm going to connect these dots, and it just shoots up right there at the 3. And then down here, it gets really close to 0. So I'm going to just kind of ride my line right above the edge there. Okay, so that's Tasha. Okay, so now for Clifton, his is the same thing, but adding 8 to every x value. So in other words, I'm just going to take every every point and add 8 to it. So the first one was 0, 13. The next one was 123. Oh, sorry, over here. Actually, it should be 0, 13 here. Not on, sorry, that was the wrong point. That's not 0, 13. Okay. And then what do we got? 123, about there. 253, so about there. You can see it's just like a little bit higher than all the other points, right? And then, 143, that's too big. So what that means is that for these points, I'm not even going to go to Desmos to figure this out. It's just 8 units higher. So this was like down here, so maybe it's like right there. This one's down there, so maybe it's like right there, okay? So that's really the biggest difference there. So now this shoots up, goes to these points, and you notice it's almost like this. It's like the same pattern. It's like the same size line, except now instead of coming down to 0, it's coming down to 8. And it's getting really close to 8, that value right there. So it's almost like an asymptote. Actually, there is an asymptote right here. I draw on a little asymptote line and going across at y equals 8. There's an asymptote line there. Okay, so how do the graphs compare? Well, they're increasing at the same rate or at equal rates. But we'll say that C of x is 8 units higher. And again, remember, in your case, it's a little different. Okay, so now the next one. All right, so now a circle equation. Okay, so this is your original circle equation. If this circle shifted this many units to the left and 5 units up, and the radius is double, what will the new equation be? Okay, so we're going to use this equation here for my example. And we're going to use these shifts instead. All right, so to help you think about this, let's figure out what the center is. Okay, so the center of this circle would be, -3, and since it's just y squared by itself, and 0. So what the shift in the right and left does is it changes your x. So this is the change in x. Down is a change in y, and then the radius is triple. So that's affecting your r. Okay, so that's changing your r value. Okay, so if the radius, we'll just say right now is r, because if you notice it says r squared, so we don't know what the radius is. So we're just going to say r is r. All right. So now we're going to go to the new center, which I'm just going to put a 1, which just means there was some change. Actually, we'll do 2. Okay. That's the first change. It means prime. Oh yeah, no, it's just prime 1. Okay. So if we shift to the right, if we shift -3 to the right 3, it basically goes from -3 to 0. Okay. Actually, I don't like that. Let's do like shift right 5. I like that better. Okay, we'll do 5 instead of 3, because I want you guys to kind of see how this works. Okay, so that means it's gonna, if I shift from -3 to the right 5, I'm gonna go from -3 to 2. For you guys that can't see what I'm talking about, if I start at -3 and I shift to the right, I go 1, 2, 3, 4, 5. So now I'm at 2, +2. And then I'm going to shift down 4. So I'm going to go from 0 down to -4. Okay, so I just basically, if I'm talking about shift right or left, I'm going to change this value. And then shift down, I'm going to change the y value. Okay, now the radius in my case has tripled. So that means we're going to multiply r times 3. So now the radius is 3r. Okay, so we'll use that to construct our equation now. Okay, so now for the x value, It's positive 2, so that means when I write the equation, I put negative 2, because maybe you switch them. And then here it's negative 4, so we're going to put y plus 4. And then for your radius, you got to remember it says the radius is r squared. So this is our r. This is our radius. It's 3r. So what we're actually going to do is take that and we're going to square it. Okay, so in other words, it's going to be 3 squared, which will be 9, and then r squared. So 9r squared is the new part of your equation. So, and just to help you guys understand why, let's say I had this as an equation, right? And I asked you, what's the center? Well, you'd say, well, that's 0. That's 0. And I asked you, what's the radius? Well, you'd say the radius is 3. Because what you do to get the radius is you take that number and square root it. So to go from here to here, we square root, right? But to go back, if I gave you 3 as the radius, you would square that in order to figure out what the equation is. So that's why we took this number 3r and we squared it, and now that's our new equation, okay? So now you do the same thing with that one. Okay, so now for each of the following functions, describe how different values of t will affect the graph. Okay, so I wrote down these templates or graphing forms for each of these types. So here's squared. So this is the graphing form for a quadratic squared, where you have your a value, h value, and your k. This one's absolute value, and if you notice, it has like the exact same template. And a lot of them are going to have an a, an h, and a k. Okay, now just to remind you, the a, what that changes to a, and we should say plus and minus a, because that's also another type of change. First of all, if this is positive or negative, that causes reflections or flips over the x-axis. Okay, so if I have the x-axis, it's going to flip my graph over that, okay? And then the a value itself, that causes vertical stretches and compressions. Okay, you guys don't have to write all this down, but I need to explain to you what all these are going to do to change a function and what the transformation is going to happen. So it's either going to, it's basically going to either stretch it like I'm stretching a rubber band vertically, or it's going to squish it, compress it vertically. Okay, so now your h, we know that causes shifts left or right, and then your k causes shifts up and down. Okay, so the same thing is going to happen with the a, h, and k with these graphs as well, and a couple on the back of this page. So you need to go in here and look at these t values and decide, if you change t, what type of change would you see to the graph, and describe that here. Okay, so you got to fill that in. If you had a change in t here, what type of change to the graph would you have? Okay, and describe that here. Based on knowing these types of changes, and also include if it's an a value like here, like what would happen if it's plus or minus. Okay, all right, so now a circle. So here on all of these, we're going to write the equation in graphing form, and these are both of these are circles. So that means that we are doing x minus h, hey, there's h again, plus and minus y minus k, there's k again, equals r squared. Okay, so a circle with a radius 9, well, if the radius is 9, remember r equals 9, right? That means to get to set up the equation, I would need to make that equal not to 9, but to 81, or 9 squared. Okay, so now we just got to fill in the rest. Okay, so the center is at, the x value is at 3, so that means I write x minus 3, and it's at negative 4y, so that means I'm going to put y plus 4. Okay, so there's my equation. Okay, same thing here. We'll start with the x value. So it's at negative 2, so I'll put x plus 2, plus, don't forget that plus in the middle, some of you guys forget that, and little squares. Okay, and then the y value is also negative, so I'm going to put y plus 3 squared, and the radius is 2, r equals 2, so to get the value to the right of your equation, you square that. 2 times 2 is 4. Okay? Now here, we need to use complete the square to figure out the graphing form of this equation. Now we've done this before, we've done this in the past weeks. Okay, so here I want to set up all my x's together. So x squared plus 8x plus, remember we're going to complete the square, and then plus y squared. And we put all our y's together with our completed square there. And then also what I need to do is all your constants need to go to the other side. So here I'm going to subtract 32 from both sides. So that means this will be equal to negative 32. Now remember, when you complete the square of the circle, if I add these values to the left, I have to add them also to the right. Okay? And now to get that completed square value, remember you do b, your b value, which is the 8x and the negative 10, you divide it by 2 and then you square it. Okay? So now, oh yeah, I'm jumping ahead. So here we go. So 8 divided by 2 is 4. 4 squared is 16. So add 16 here and here. And then negative 10 divided by 2 is negative 5. Negative 5 squared would be positive 25. So add 25 here and here. Okay, so now I want to factor these out. Some of you guys have seen this a bunch of times, so you might be pretty good at this by now. So now this will be negative 32 plus 16. That's negative 16. Negative 16 plus 25 will be 9. All right. Now to factor these out, I could use the x, and I'm going to have to do it twice. So over here, I would have 16x squared, 8x on the bottom. And on the one on the right, I would have 25x squared. Sorry, y squared actually. And then negative 10y. Okay, so these two numbers here, two numbers that multiply to 16, add up to 8 would be 4x and 4x. And for this one, this would be negative 5y and negative 5y. Because negative times negative is a positive, and negative plus a negative is a negative. Okay, so now I can just add those right in here. So x plus 4 times x plus 4. And then y minus 5 times y minus 5. And then just condense those into one factor squared, since they're the same for both. And then you set that equal to 9. And then if I asked you what's the center, you would say, excuse me, you'd say the center is at negative 4 and positive 5. And then the radius is equal to 3. Okay? Now, it doesn't ask you for that, but I'm just throwing that in there. Okay? So let's flip the page. Okay, so now you're given an equation, and here's the equation we're going to use. That's your equation for your homework. State the equation of the parent graph, okay, and then describe how it's transformed from the parent graph. Okay, well, the key thing I'm looking for in this form is that exponent. It's cubed. So I know that this is going to be a cubic function. And cubic functions are f of x equals x cubed. Okay? But what are the transformations? Okay, so remember, just like before, just like the quadratic, it follows the same pattern as the number in the front's your a, plus and minus. The number, sorry, some issues here. Okay, the numbers inside here would be x minus your h, and then plus your k out here. Okay, so first remember that causes plus and minus causes reflections, and you notice it's negative, so that means it's going to reflect over the x-axis. Okay, then it's the value of 3, and remember, anything bigger than 1 is going to be a stretch. Anything that's less than 1, like a 1/2, 1/3, that would be a compression or a squish. Okay, so this would cause a vertical stretching. You want to say vertical stretch because there's also a horizontal stretch. We just haven't dealt with that yet. Okay, so vertical stretch by factor. A lot of times you'll hear the word factor of, and that's your number that it's looking for if it's asking you what the factor is. By factor of, geez, I'm running out of room here. Factor of 3, okay? And then the next part, plus 4. Okay, remember, you have to think reverse, right? So positive 4 would mean I'm actually going to the left. So that's left 4 units. And then the k value is -5, and that would be down 5 units. Okay? All right, so now these last ones down here, here you start with a function. We're going to graph it, but we're also going to use we're also going to state what the family of functions it's from, or in other words, the parent function, and describe how each coefficient or each number in here transforms the location or shape of the graph. Okay, so we're going to talk about how all these numbers change the graph. So first, let's figure out what the parent function is. Okay, we're going to do that for actually all of these. So I'm going to go ahead and write parent here for every box, because we're going to need to know that for all of these in order to figure out how to graph it, or how to graph it or create the equation. Okay, now this one, this would be y equals 1 over x. So that's your parent function, okay? But now we need to know how those different numbers change the function. Okay, so let me show you how that works for this is called a reciprocal function, because it's like flipping x over, so it's reciprocal. Okay, so the number on the top, that's your a in this case. All right, and you can put a in the front, but it's just simpler to put it on top. And then your h is that same number next to x, so x minus h, and then plus k over here. All right. So now that means that plus 2 would cause a shift to the left. So that means it goes left 2. And then the k happens to be minus 3, so that means it's going to go down 3. Now, in order to graph this, you got to know what it looks like. So I'm going to give you a quick little sketch of what it actually looks like. The parent function, I mean. Okay, so the parent function for 1 over x, it's the kind of the center of the graph is right here at 0, 0, just like the rest of these are all the centers at 0, 0, except there's also asymptotes in the middle. So there's like these little asymptotes. I can't show you here because they're right on the x-axis, but they'd be dashed lines going across here and here. And you have these little hyperbolas, or it's like a curve that kind of like rides along the x-axis and then starts to curve and go back up towards the y-axis on both the top left and the bottom right. Okay, so now that middle point 0, 0 is shifting according to these shifts. So that means it's going left 2, and then down 3. So now that middle point's here now. So that means your asymptotes go vertically from there and horizontally from there as well. So those two asymptotes are now kind of shifted down to the left. So now it's still the same pattern. I still have this hyperbola up here to the left. And remember, it's a sketch, so you do your best here. And then a parabola going down to the bottom. Now remember, you guys need to pay attention to your values. Yours are different, right? Like mine was positive here, and mine was negative. Yours is negative here and positive here. So that means obviously it'll be in a different location. Okay, so now let's do the same thing here. Okay, so the parent function is y equals square root of x. All right, now this is very similar to like kind of how this one is set up. A lot of them are actually set up a lot like this one. This is the kind of one that looks a little bit different, but still same idea. To change a square root function, or radical is another name for it, is the number in front is your a, Under the radical, that's your x minus h. And outside the radical to the right, and actually I kind of drew that radical line a little bit too far. I don't want to draw it too far because the x minus h only covers the x and the radical only covers the x and the h, and then I have plus k on the outside. Okay. Now there's no change to h, obviously in the middle or inside, and there's no k also on the outside, but there is a change to a. Remember, I told you that causes vertical stretches or compressions. And now that since that number is bigger than 1, it's going to be a vertical stretch of 2. Or, if it asks you what's the factor of, or what's the vertical stretch or factor, you'd say if it's a factor is 2. Okay. Now, to understand how to graph this, you need to know what it looks like. Now, a parent function of a radical looks like this. It starts in the middle. It kind of just raises up and goes to the right like that. Okay? So let's actually figure out what those points are. Okay? So let's start at 0. I know it's going to be start at 0 right in the middle because there was no shift left or right or up and down. And we'll plug in 1, 2, 3, 4. And we'll see what we get. Okay? All right, so to get the y value, I'm going to plug in these values into that function. So 2 times square root of 0, 2 times square root of 1, 2 times square root of 2, 2 times square root of 3, and 2 times square root of 4. Okay? Now, 2 times square root of 0, no square root of 0. First I take the square root, so 0 times 2, that's equal to 0. So my first point's at 0, 0. Then, square root of 1 is 1, times 2 is 2. Square root of 2, that's like a decimal. I don't want to use that number, so I'm going to skip that one. Square root of 3, that's also a decimal. I'm skipping that one. Square root of 4, I know that one, that's 2. And then I multiply 2, so I get 4. So notice how I skip some of these values. So when you're dealing with radical functions or square roots, you're really only going to plug in numbers that help you get like whole numbers, because you don't want to plug something in and get like a decimal. I don't want to graph that. I don't need to. Okay, so my next point is 1 and 2. 1, 2. And point after that would be 4 and 4. Now so basically it's a curve that goes like this. Okay, now the normal function actually kind of goes like this. Goes here and then like that. That's the parent function. So you can see what I mean by a vertical stretch is it basically stretched this thing up. It pulled it up. Okay, because that's what the parent function, it would be about here, but it stretched it up. So you can imagine that this would stretch it even more when you do the 3. Okay, so now this one, parabolas, we know right away that's going to be x squared. And when I'm looking at this one, this is a cubic function, so that's going to be x cubed. All right, so remember with these ones, they're very similar in that you're going to have y equals a times x minus h squared plus k, and then you'll pretty much have the same thing over here, a times x minus h, except it'll be cubed plus k. And that's kind of the crazy thing about parabola versus a cubic function, is that a parabola is the same as a cubic function, except the other half is pointing down instead of up. So it's like one half is pointing up and the other is pointing down, whereas here at parabola, they're both pointing the same direction. Okay, so that's why these are so similar. So let's put in what we know. Okay, well, the h and k in a parabola, if you remember, let me just kind of do a quick parent function of what it looks like, comes from the vertex. So the vertex on this graph, and notice how I made a new one over here, because I was going to put it on here, but it just got messy. So I put it right here. So my vertex here is 0 and -5. So 0, -5. So what that means is that here I would put in 0 for h, and then here I put in -5. So let's simplify that a little bit. So a, and then x minus 0, I don't need to put the 0, so it's just basically x squared minus 5. But notice I don't have an a value, so I need to find the a value. And notice it gives you a point. And by the way, this point is 2, 5. It's kind of hard to see. But we can use that point to figure out the a value. So here, I'm going to use this 2, 7 in my graph and plug that in. Now, any point on your graph works. I could use this one as well, negative 2, 7. I could use this one right here at 1 and, what is that, 1 and negative 2. But the only one I can't use is the vertex, because if I plug in the vertex, it cancels out the a, and then there's nothing to solve. Okay, so let's plug in 2, 7. So the y value is 7. X value is 2. Okay, so now all I'm doing is solving for a. Okay, so now here 2 squared is 4. So this is 4 times a. And then I just keep solving. So add 5 here. It's going to be 12. And then divide by 4. So a equals 3. Okay, so now my a is 3. So now I can complete the equation. So the a is 3. And then I have x squared minus 5. So 3x squared minus 5 is my final equation. So basically I had to do a little legwork in figuring out the a value, but the vertex part of it is the easy part to find. Okay, so now same thing here. So here's my locator point, as we call it for the cubic function. And it's right here at -1 and 3. -1 and 3. And remember, with the x value in these, I want to change that. So if that's -1, I should put +1 here, x plus 1, cubed in this case. Remember, cubed, not squared. And then here, +3. So now again, same thing. I need to find the a value. So pick a point other than the one in the center. So I can pick an easy one like this one right here. Or you guys could pick that one. Just any point that kind of lines up somewhere on the graph, or that one would work too. But I like this one because it includes a 0, and zeros usually make things a little easier. So that's 0, 2. So the 2, so I'm basically plugging in 0, 2. The 2 I'm going to put here. And the 0 I plug into x. And cubed, you can easily make the mistake by forgetting that's a cube and putting a square, because we work with squares so much. Okay, so 2 equals 0 plus 1 is 1. And then 1 cubed is 1, because that's basically, you're multiplying the 1 3 times. 1 times 1 times 1. So basically it's 1a, and then plus 3. Really, I don't need to write the 1. No, I won't include that in the next step. So minus 3, minus 3. So a equals -1. So when I write the equation, since it's just a -1, I'm only going to put negative in front and not the 1. And then I know that the rest is +1 and then +3. So x plus 1 and then +3. Now, one thing to note is that your locator point is at +1, which means you're going to have a -1 here when you cube it. I need you guys to remember that when you cube something, you're multiplying it 3 times. So when you guys do your problem, it's going to be -1 times -1 times -1 again. So think about that. -1 times -1 is +1. And then times -1 again is -1. So it will not be positive. So just keep that in mind when you're working with those cubes, that if you have a negative number and you're cubing it, it will still be negative. Okay? All right, and that's your final equation.